The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
For the example oxidation number, provide the oxidation numbers for the following. Beginning here with our sodium cation here, we see that the oxidation number for that is going to be +1, and that's due to rule A. And if we recall, rule A states monatomic ions have an oxidation number that is equivalent to their charge. Thus, since monatomic ions have an oxidation number that's equivalent to their charge, the same applies for our chlorine here as well. The oxidation number is going to be -1, and it's rule A that applies. Next, looking at oxygen here, the oxidation number is going to be 0, and that's because of rule B. And if we recall, rule B states all elements that are pure have an oxidation number of 0. Thus, our nitrogen will also have an oxidation number of 0 because of the same rule. Now, looking at water, right, the hydrogen is going to have an oxidation number of 1, and oxygen is going to have an oxidation number of 2, and that's because of rule C and D. And if we recall, rule C says hydrogen's oxidation number is 1 when bonded to a non-metal, and oxygen's oxidation number is -2. Great. Now, getting back to our slide, next we have here sodium hydride, and we know the oxidation number for sodium is +1. However, this time the oxidation number for hydrogen is -1, and that again is because of rule C. And if we go back, we see that it says right here that hydrogen's oxidation number can be -1 when bonded to a metal. Thus, that is why our oxidation number here is -1. Now, looking here next at dichlorine monoxide, the oxidation number for our chlorine is actually +1, and the oxidation number of our oxygen is -2, and that's because of rule E. Now, going back, rule E tells us that the halogens typically have an oxidation number of -1. That's not the case for us. Here, the notable exception is when chlorine, bromine, or iodine are bonded to oxygen. Thus, our chlorine has an oxidation number of +1. Wonderful. Now let's move on to our next slide, and we'll focus a little bit more on polyatomic ions. Great. Looking here, example finding oxidation number for polyatomic ions. What is the oxidation number of carbon and bicarbonate? Now, I would just like to take a moment now, go back and read rule F for us again, because we're going to be applying this. The net charge on polyatomic ions is equivalent to the sum of the oxidation numbers of the elements that make up the polyatomic ion. Thus, here we know that for our bicarbonate, right, the sum of the oxidation numbers is going to be -1, is going to be -1. We know the oxidation number for hydrogen, that's +1, right? Carbon is what we're after. Furthermore, we know the oxidation number for oxygen is -2, but we have to account for the 3 oxygens that we have, right? And that is all equal to -1. Now, if we isolate here for our carbon, we find that the value is just going to be -1 plus 6, and that is going to be equal to +4. That there is the oxidation number for carbon. And you can just use that strategy and isolate for the atom of interest. Great, let's now continue to our next slide. Beginning here with our, what are we being asked? Provide the oxidation numbers for the following.